This is 5.4, the quadratic formula. You can use this to solve any quadratic equation. Normally, you'll use it when you can't factor, as factoring tends to be your first way to solve a quadratic equation. So make sure that you write this formula down. You're going to use it whenever you solve a quadratic equation, which is in standard form. Ax squared plus bx plus c is equal to 0. Now it's not always going to be equal to 0. You may have some number here. If that's the case, you just move it over to the other side, and I'll show you some examples of that. Another important thing is to make sure that you use parentheses here for b, and also there underneath the radical. If you're plugging it in the calculator and you have -2 squared, your calculator will give you -4, which is incorrect. Okay, that's no good on that. It needs to be positive. So if you're plugging it in the calculator, make sure that you put that in parentheses so that you get the correct answer out. Remember that you will always have two answers because of the plus or minus sign here in the middle. So once you simplify everything, you want to make sure that you break it down into the part where you add it and the part where you subtract it. So please be aware of that. Okay, you also need to be aware of how many real solutions you're going to have. Remember, when we are solving a quadratic formula, we're looking for the zeros. Okay, so the zeros are where your quadratic function crosses the x-axis. Okay, so if you have something that looks like this, you're going to have two solutions. If it falls on the x-axis, you'll have one solution there at the vertex. If it does not cross the x-axis, something like this, you can still solve it, but your solutions will be imaginary. Okay, so we'll be dealing with I again. So we have what's called the discriminant, and that's the value underneath the radical. Okay, so remember this was underneath the radical in the formula. And this is just going to tell you how many solutions, how many real solutions you're going to have. So if you get a positive number under here, you're going to have two real solutions. If you get 0 under the radical, so you have the square root of 0, you'll have one real solution. And then if it's negative, you'll have no real solutions, which means you're going to be dealing with imaginary numbers in your answer. So here are some examples. We could actually factor out this first one if you wanted to check your work, or just so you can see that we're going to verify this. So if you wanted to factor it, you would see that that would be x plus 3 times x minus 1. Okay, and remember when you solve it, you have to set them equal to 0. So that would give you x equals -3, and then you'd have x minus 1 equals 0, x is equal to 1. Okay, so we're looking for the solutions -3 and 1. And I'll show you how to do this in the quadratic formula. So first you need to identify your coefficients. So a here is 1, b is 2, and c is equal to -3. So all you do is plug it in. Remember, your quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So you just need to plug it in. Negative, always put your b value in parentheses. Square root of 2 squared minus 4ac all over 2a, which is 1 here. And then you just simplify it. So we have -2 plus or minus the square root. 2 squared is 4 minus 4 times 1 is 4 times -3 is -12. 2 times 1 is 2. So if we're looking at our discriminant, which is the square root of 4 plus 12, remember this double negative here, which gives you the square root of 16. Okay, so that's a positive number, so you know that we're going to have two real solutions. So positive. So let's continue. So we have -2 plus or minus the square root of 16 over 2, which is -2 plus or minus 4 over 2. Now this is where you get your two solutions. You have the positive, -2 plus 4 over 2, which is 2 over 2 equals positive 1, which is what we got over here when we factored it. And then the negative side, so negative 2 minus 4 over 2 is equal to negative 6 over 2, which is negative 3. So as you see here, we got the two same answers as before. So here x is equal to 1 and negative 3. Okay, so factoring or the quadratic formula either will work for these examples. Here in the second one, it's not in standard form, so our x is on the wrong side, so in order to move it, we have to subtract it, so minus 3x on each side, which will give us 6x squared minus 3x plus 3 is equal to 0. A is equal to 6, B is equal to negative 3, and C is equal to 3. And this is where your parentheses are going to come into play. So we have negative 3 here, plus or minus the square root of negative 3 squared minus 4 times A times C, all over 2 times A. So be careful here, make sure that you do all your math correctly and you catch those double negatives. So we're going to have positive 3 plus or minus the square root of 9 minus 4 times 6 is 24 times 3 is going to give you 72 over 2 times 6 is 12. So keep reducing, and this is all equal to x. And here we're going to get some imaginary numbers because we have 3 plus or minus the square root. 9 minus 72 is negative 63 all over 12. So this is where you want to go ahead and simplify, come up here, that radical. So I'm going to go ahead and simplify it up here in blue. So we have the square root of negative 63. So remember, we're looking for factors of this that are a square root. So we'll have 9 and negative 7. So this is equal to the square root of 9 times the square root of negative 7. So we have 3 square root of negative 7, and we don't want that negative in there, so it's 3i square root of 7. Okay, so that's that radical simplified. So I'm just going to rewrite it. 3 plus or minus 3i radical 7 all over 12. Now you can go ahead and reduce it. They all divide by 3. So we're going to divide all of our numbers here by 3. Okay, so 3 divided by 3 is 1, plus or minus 1i square root of 7 over 4. And that's all equal to x. I will take your answers in this form. You don't have to rewrite it in the positive and negative. That's it for the examples. If you need more help, send me an email, shoot me a remind, or see me later in class. We'll also be working on it in class on the stations, and you do have one Khan Academy homework for this.